Hi, this is Steve from CatStar Sky Ranch. If you haven't heard of us, CatStar Sky Ranch is a site in northwest Texas where amateur astronomers can set up remotely accessed observatories to take advantage of the dark skies in this region for their deep sky imaging. Of course, if you're going to do remote imaging, one thing you have to have is a good internet connection so you can download commands to control your equipment and upload the imagery you acquire. A reliable connection is critical, and fast upload speeds allow you to retrieve your imagery without taking all day to do it, especially when you've got a number of people all trying to do it at the same time. In the past, we relied on buried Ethernet cable for internet communications. This cable is about 300 feet long and is buried inside PVC pipe to keep the critters from chewing on it. This has worked pretty well so far, but putting in buried cable is labor intensive and expensive. It usually costs a couple of $100s to rent the trencher for a day, and then you have to clean it up before you take it back to the dealer. There's got to be a better way. So what I decided to try out was a long-distance outdoor Wi-Fi system. These are easy to set up and usually aren't terribly expensive. There are a number of these systems on the market. The one I decided to try out was from Hawking Technology, their HOW12ACM system. I'll put a link to it in the video description. Normally, the strength of the signal from a Wi-Fi unit decreases pretty quickly as you move away from it. The trick is to use two Wi-Fi units. Here's a picture from the Hawking Technology website. You use one HOW12ACM unit in what is called access point mode. It is connected to your internet source. This unit uses line-of-sight communications to a second HOW12ACM unit operating in repeater mode at your remote location. All your other devices at the remote site, computers, cameras, etc., are linked to it. Using this point-to-point communication system results in a much smaller loss in signal strength over distance. Hawking Technology claims that this setup will allow line-of-sight communications for distances up to 1,000 feet with minimal reduction in transfer rates. Here are the hardware components of the HOW12ACM system. On the left is the Wi-Fi transmitter receiver. The two antennas are detachable, which makes it easier when you are transporting it and setting it up. In the center is the PoE injector. PoE stands for Power over Ethernet. What this device does is supply power to run the Wi-Fi unit through the Ethernet cable. This way you don't have to have a separate power supply for the Wi-Fi unit. The black box is the power supply for the PoE injector. This plugs into any regular outlet. Now, if this Wi-Fi unit is operating in access point mode, this Ethernet cable is attached to your internet source. On the other hand, if the Wi-Fi unit is operating in repeater mode, this cable can attach to a splitter box or a router that your other devices at the remote site, computers, cameras, etc., can attach to. Finally, this Ethernet cable goes between the PoE injector and the Wi-Fi unit. Since the PoE injector supplies power to the Wi-Fi unit through this cable, the cable can actually be quite long, allowing you to set the Wi-Fi unit up at some distance from your internet connection. Hawking Technology pre-configured the two HOW12ACM units before they shipped them to me so they'd be able to talk to each other, and at no extra charge, which was nice. They supplied the software where you can do this yourself, but in my case, it wasn't necessary. So setting them up was simply plug and play. Okay, here's the layout of my test of the Wi-Fi system at CatStar Sky Ranch. In the test, internet speeds were measured at 4 locations. The first location was in the ranch house, where the fiber optic cable from the local internet service provider comes in. Here it's connected to a router that provides Wi-Fi for the ranch house and also Ethernet connections for other devices like computers. The laptop was connected directly to this router. The second location was on the south side of the ranch house, where the HOW12ACM operating in access point mode was mounted on a wooden post facing in the general direction of the observatories. The PoE injector for this Wi-Fi unit was plugged into the router in the ranch house and connected to the Wi-Fi unit using a 100-foot-long Cat8 Ethernet cable. As mentioned earlier, the HOW12ACM doesn't have to be located near the internet connection, since the PoE injector can provide both internet and power to it at a distance. The third location was at 170 feet southwest of the ranch house. Here, the second HOW12ACM in repeater mode was set up on a small tripod. Its PoE was powered by an extension cord from one of the observatories. It was in direct line of sight with the first Wi-Fi unit up at the ranch house. After measurements were made at the third location, the second Wi-Fi unit was moved to a spot 240 feet away from the ranch house. This was next to an existing roll-off observatory. It was also in direct line of sight with the first Wi-Fi unit up at the ranch house. So, what kind of internet speeds would I measure at each of these locations? And what decreases in internet speed might I see as I got farther away from the internet source? At each of the four locations, I measured internet speed using a Windows 10 laptop with Google Chrome running the fast.com utility. This utility provides measurements of both download and upload speeds in megabytes per second. I'll put a link to this utility in the video description. So now for the results. At the first location, at the router in the ranch house, I measured a download speed of 52 megabytes per second and an upload speed of 46 megabytes per second. This was with the laptop connected directly to the router. These speeds represent the maximum values available to the ranch from the internet service provider. All other measurements should be equal to or less than these. For the second location, I measured the internet speeds at the end of the 100-foot Cat8 Ethernet cable. This was to see what drop in speed might occur due to the length of this cable. To make this measurement, the 100-foot Ethernet cable was plugged directly into the laptop. Here I got a download speed of 50 megabytes per second and an upload speed of 45 megabytes per second. So there was only a small drop in internet speed over the length of this cable. The measurement at the third location was the first real test of the long-distance Wi-Fi system. Here the laptop was plugged into the PoE for the HOW12ACM operating in repeater mode. To my surprise, I got a download speed of 50 megabytes per second and an upload speed of 45 megabytes per second. No change in internet speeds from what was going into the first Wi-Fi unit up at the ranch house. So over this distance, the long-range Wi-Fi system seemed to be working quite well. After moving the second Wi-Fi unit and laptop to the fourth location next to the roll-off observatory, I measured a download speed of 50 megabytes per second and an upload speed of 45 megabytes per second, the same as at the third location. So, over a transmission distance of 240 feet, I saw no measurable decrease in internet speed. I was pretty impressed. I have a feeling that, if I had made measurements even farther away from the ranch house, I still would be seeing high internet speeds. Now for comparison, I measured internet speeds at the end of the buried Ethernet cable that was run from the ranch house to the roll-off observatory. Here I got a download speed of only 9 megabytes per second and a similar upload speed of 9 megabytes per second. So the long-distance Wi-Fi system turned out to be 5 times faster than the buried Ethernet cable. I didn't expect that. So what are my conclusions from the test? While I didn't test it out to 1,000 feet, Hawking Technologies claimed that their system would allow line-of-sight communications over substantial distances with minimal reduction in transfer rates seemed to be true. Their long-distance Wi-Fi system produced much better download and upload internet speeds than buried Ethernet cable, and it was certainly much easier to set up. No more wrestling with a heavy trencher. The system was easy to set up, just plug and play, and worked perfectly from the start. The Wi-Fi units are weather resistant, although I don't know if they'd stand up to a big hailstorm. You can get replacement antennas if they should get damaged. So, unless someone insists on doing things the hard way, all future internet communications for remote observatories at CatStar Sky Ranch will be done using this long-distance Wi-Fi system. Based on my experience, I would definitely recommend something like this for similar long-distance applications. If you have any questions, leave them in the comments section below. Okay, that's about it. I hope this video was useful. Thanks for watching. And to all you astronomers out there, clear skies.